Hello everyone. Okay, so in this video we're going to be looking at the intersection of a line and circle, and then we're going to be looking at the relationship of a tangent line to a circle, and then hence finding the equation of said tangent line. So first things first, we're going to be looking at the intersection of a line and a circle. So don't know if you're aware, but in algebra 2 we've done the process for this. So we've done solving simultaneous equations for linear and non-linear equations. And that's the same process here, because as we know, solving simultaneous equations also allows us to find the points of intersection between two equations or two functions or two graphs, etc. So the intersection of a line and a circle is, I'm going to be solving simultaneous equations, and then we're going to be using the substitution method. Yeah, so the substitution method is outlined below. So we label our equations 1 and 2. We rearrange the linear expressions in the form y equals blank, x equals blank. We're going to substitute this expression into the other equation. Then we're going to find the value for x or y, so whatever one we chose. We're going to get a quadratic equation for that. Solve that quadratic equation. We're going to get two values for x. Then we're going to substitute each of them values in to one of my original expressions, get the corresponding value of the second variable, and then that's our point of intersection. So if you want more in-depth examples of this, I do recommend watching my video in Algebra 2. I'll link it here if I remember. Such a YouTuber. You know what I mean? Right. So, find the point of intersection of the line x plus 3y is equal to 10, and the circle x squared plus y squared is equal to 50. So, first things first. So I write down my equations. Yeah, so I have x plus 3y is equal to 10. Then I have x squared plus y squared is equal to 50. So I'm going to, so step 2 then, I'm going to rearrange equation 1. So I'm going to rearrange equation 1. So I'm going to get x on its own in this one, because I have a 3y and I have to divide by 3, and it's like a whole thing, and it's really annoying. So x is on its own, so I'm just going to do x. So it's going to be equal to, x is equal to 10 minus 3y. Boom. Right, step 3 now is I'm going to sub x into the equation 2. So I'm going to sub it in now. So I have 10 minus 3y squared plus y squared is equal to 50. So I just replaced x in my second equation with the 10 minus 3y. Now I expand this bracket out. If I expand it out, I'm going to get 100 minus 60y plus 9y squared. Then I have the y squared here is equal to 50. So I'm going to take this expression, I'm just going to move it up here just so I have more space. So I'm going to simplify my left-hand side, gathering my like terms. I'm going to have 10y squared minus 60y plus 100 is equal to 50. So I'm going to be left with simultaneous equations. So I'm going to bring this 50 over. So I have 10y squared minus 60y plus 50 equals 0, because I'm going to bring it over, make it a minus. 100 minus 50 is 50. Now I can sub these into my minus b formula, or I can factorize. For this one, I'm just going to factorize, because I'm like a legend like that. I could just stuff factorials in my head, you know what I mean? But I'm going to be some factorizing, but if you want to use a minus b formula, go ahead, you know what I mean? Like, I don't really care. So, I noticed first, oh my god, hey, 10's the highest common factor of all these. So I'm going to take it at 10, right? So I can divide across by 10 in a minute. So I have 10 factor out 10, and I'm going to be left with y squared minus 6y plus 5 is equal to 0. I'm going to divide both sides by 10 because I can, and if I can, I will. You know what I mean? So I'm going to divide both sides by 10 to get rid of it. And now I'm just left with y squared minus 6y plus 5 is equal to 0. Now I have a very easy simultaneous quadratic equation. So two numbers to multiply to get 5, but add to get minus 6. This is going to be y minus 1 and y minus 5 equals 0. So I'm going to have y equals, y minus 1 is equal to 0. Y minus 5 is equal to 0. So y is equal to 1. Y is equal to 5. So now I have my y values. So now I need to find the corresponding x values to get my points of intersection. So I'm going to sub it into equation 1 because it seems easier, you know what I mean? So back up here now. So this is our final step. Yes, it's step 5. So I'm going to shove it in now. X plus 3 y equals 10. So I have y is equal to 1 and I have y is equal to 5. Let's find the corresponding x values here. So x plus 3 times 1 equals 10. X plus 3 times 5 equals 10. X plus 3 is equal to 10. X is equal to 7. And then I have x plus 15 is equal to 10. X is going to equal minus 5. So, very interesting. So, these are my corresponding values. I'm going to use different colors here. Sure, we'll go with a salmon. Oh, that's not a salmon. Well, you get the points, right? So, my points of intersection are going to be 7 and 1. So, when x is 7, y is 1. And it's going to be minus 5 and 5. So when x equals minus 5, y is equal to 5. So these are my points of intersection. So this is where the line intersects the circle. And you know what? It's so great for me telling you this is where they intersect. But let me just show you. Now, so we're going to go to GeoGebra. A little transition right here. Hello, future me here. So I was a bit of a dum poo poo head, and I actually didn't have my microphone set up at this moment. But what I'm just doing here is I'm just plotting out on GeoGebra. You know what I mean? So there's me being a dum stupid head and talking like anyone can hear me. But anyway, I'm just plotting the circle and the line onto GeoGebra. That's all I'm doing. I'm just putting the bits on. You know what I mean? Look, seems like I got it. Right? So I'm talking away, don't know what I said there. But we see there intersects at 2 points. So this intersects at the point minus 5, 5, which is what we got in our question. And then it also intersects at the other point down here on the right, which is 7, 1, which again we got. So if you go back, that's what I said here. Yes, right, these are my points of intersection. So that's how I proved it graphically there. If you want more examples on how to do this, I do recommend watching my other video. Fine. So now, what about if a line is tangent to a circle? So a tangent line to a circle, a line is said to be tangent to a circle if and only if it intersects the circle at 1 point only. So it's called a tangent line because the line is perpendicular to the radius at that point. So here's an example. Here's a little diagram. That line is said to be tangent because it intersects this point P. Yeah. But if I drew a line from the center to this point P, it's going to be perpendicular. Yeah. To the tangent line. So it's going to be making an angle of 90 degrees. Right. So that is also why it's called a tangent line. So let's look at an example here. If this will load from what? So this question asks us, prove that the line 2x plus y is equal to 10 is tangent to the circle x squared plus y squared is equal to 20. So now I just need to do my steps in the previous question, but I should be only left with 1 point of intersection. So I have here 2x plus y is equal to 10. And x squared plus y squared is equal to 20. So I'm going to get let's have a look here. Would I get x or y on its own? I'm going to get y on its own. Why would I get x on its own? It has like a 2 in front of it. I have to divide by 2. No. If I was fractions? No, we're not using fractions. We're going to pick y because there's There's nothing going for it, you know what I mean? So I'm going to pick y because it's easier. So I'm going to rearrange y. So I have y is equal to 10 minus 2x. Bada boom, bada bing. Now I'm going to sub into equation 2. So I'm going to sub into equation 2. So when I have y here, I'm going to put in 10 minus 2x. So I have x squared plus 10 minus 2x squared is equal to 20. So I'm going to expand this bracket out now. If you don't know how to expand a bracket, watch my previous video on that. But I have x squared plus 10 minus 2x times 10 minus 2x is equal to 20. X squared plus, I'm going to multiply this bracket out now. So I have 100 minus 40x plus 4x squared is equal to 20. Simplify my left-hand side, gather my x squared terms. I'm going to have 5x squareds. I'm going to have a minus 40x. I have a plus 100, and it's equal to 20. And then I'm just going to continue my workings up here. Then I'm going to bring this 20 over, because I'm left with a quadratic equation, so I want to bring everything to the left. So I have 5x squared minus 40x plus 80 equals 0. So now I have this quadratic equation here. Again, you could use a minus b formula if you want. Who am I to judge? But I am going to judge, and I'm going to factorize because it's actually proper quicker. So I notice here 5 is a common factor. So I'm going to take out a 5, and I'm going to be left with x squared minus 8x plus 16 equals 0. I'm going to divide both sides by 5. So that 5 goes, and 0 divided by 5 is 0. So I'm left with x squared minus 8x plus 16 is equal to 0. Two numbers that multiply to get 16 but add to get minus 8. Well, it's going to be x minus 4 times x minus 4 equals 0. Right? So you see here of x minus 4. Well, it's going to give me both the same answer, isn't it? It's going to give me x minus 4 equals 0. X is equal to 4. Right, so if I solve both them brackets out using my product of 0 rule, I have x is equal to 4. So I only have one x value, and if I only have one x value, I'm only going to get one y value. So we're going to now sub this value in. Now, for me, for me, I don't want to get into schematics of it, but sometimes it gets a wee bit confusing when we add the 4 into our circle equation, because just trust me on this, sometimes it just doesn't work out proper. I would always sub this, I always sub the values back in to the one for the line. That's for me, that's how I do it anyway. It's just something to be careful of. It will work out a lot of the times, but sometimes you can get one that's tricky, and I might show you why in a second. So I have x is equal to 4. So I'm going to sub in now. So sub into equation 1. So I have here 2 times 4 plus y equals 2 times 4 plus y is equal to 10, I believe. Yes, it is. So I have 8 plus y is equal to 10. I have y is equal to 2. So therefore, it intersects at the point 4, 2 only. Yeah? So it only intersects at the point 4, 2. So if I go back to my GeoGebra. Hello, future me here again. Yeah, so it just seems like when I'm on GeoGebra, I just don't have my microphone on, which is very annoying. Yeah, so I'm doing the same thing. Yeah, I'm just plotting on GeoGebra just to show you what it looks like. I'm just talking away. So what was this one? We were looking if a line was a tangent to a circle. So I was just plotting out the answer. I was plotting out the two graphs they gave us, and then we're seeing if it's tangent. Oh, I think I'm struggling there to type in the equation of circle. think I'm going a bit cross-eyed there, trying to figure it out. Oh no, I got it. Oh, I got it there. Oh, there we go. I have the equation here. So as we see here, the red line, which is the line function given to us, it intersects the circle, the orange circle, and it does intersect at 1 point and 1 point only. So that point is 4, 2, which is what we got in the question in the example. So yes, I think I'm going back to the main screen now in a second. I think. And that is what we said there. Gorgina. Right. So, and finally, the last section in this video is finding the equation of a tangent line to the circle. Right, if it will load for me, that would be great. So we want to find the equation of a tangent line to a circle. So sometimes they will give us a circle and a point, and they will ask us to find the equation of a line that's tangent to it. So to find the equation of a tangent to a point on a circle, we do the following steps. So first, we find the slope from the radius. Find the slope of the radius from the center point to the given point on a circle. So they're going to give us a point on a circle. And then we find the perpendicular slope to that. Because if you recall, I was saying the tangent line is going to be perpendicular to the line of the radius. And then this will be the slope of our tangent line. And then finally, we'll use our new slope. We'll use our point. And then we'll go sub it into our equation of a line formula as listed below here, which is in your log tables, BT dubs. Right, and then we find the equation of a tangent line. So let's do an example here. So find the equation of a tangent to the circle x minus 1 squared plus y plus 2 all to be squared is equal to 25, and the point minus 2, 2. So first things first, right? Draw a sketch for the love of Brittany. You know what I mean? Draw a sketch plus. Because there's no point, you can't visualize this in your head, right? So, draw a little circle. Bada boom, bada bing. If it will load, gorge. Right. So, let's find my center point first. So remember, so the x minus h all to be squared plus y minus k all to be squared is equal to r squared. So remember, that's the equation of a circle with a non-zero, zero center. So I have minus h is equal to minus 1, h is equal to 1, minus k is equal to 2, k is equal to minus 2. So my center point then is going to be 1 minus 2. So I'm going to put that point in there. 1 minus 2. And then I have the point on the circle, which is minus 2, 2. And I'm just going to guess it's up here. So minus 2, 2. So I'm going to guess it's around that general direction. So, first, let's connect them 2 points together. So let's find the slope of this blue line now. Yeah, because remember, we're still on a coordinated plane. So let's find the slope of this blue line. So we're going to use our slope formula. So remember, m is equal to y2 minus y1 all over x2 minus x1. So x1, y1, x2, y2. So I'm going to have 2 minus negative 2 all over minus 2 minus 1. So I'm going to be left with 4 over minus 3, which is just basically minus 4/3. So the slope of this line is minus 4/3. But now, if you recall, ladies and gentlemen, we want to find the equation of a tangent line. And if you remember, right, so it's a tangent line, so the slope is going to be perpendicular to this line. So the slope, we're going to find the perpendicular slope now. So let me just sketch out my perpendicular line here. Oh, that was no good. Right. Boom. Ding. Right? So I want to find the equation of that line. Right? You'll do a bit neater in your exam anyway. So, that's minus 2 there. So now I have the slope of this line, which is minus 4/3. So the slope of tangent, right? So we're going to find the perpendicular slope. So it's going to be perpendicular to minus 4/3. So remember, perpendicular slope, I flip it upside down, change the sign. So it's going to be 3/4. So that means the slope of this line equals 3/4, because I flipped it upside down and changed the sign. And a point I have on the line is minus 2, 2. So now I have my slope. I have my point. I'm going to sub this now into my equation of a line. So y minus y1 equals m times x minus x1. So I have y minus 2, right, because my minus my y coordinate here, equals 3/4 bracket x minus negative 2. Y minus 2 equals 3/4 x plus 2. So I have y minus 2 equals 3/4 x plus 6/4. Y is going to equal to 3/4 x plus 6/4 plus 2. Y equals 3/4 x plus 14/4. And 14/4 breaks down to 7/2. So that's the equation of line. So you can leave in this form y equals mx plus c, or if you want to be proper bougie, you can multiply across by 4 and get it something else. But this is A-OK. So that's the equation of my tangent line. So let's check ourselves using GeoGebra. So let's go back to the GeoGebra. Hi, future me again. It's the last note you're going to get from me. Again, you get the point now. I'm just plotting our answers. So I'm plotting the line, the equation of the line I found. And I'm plotting the circle that they have given us. So, yeah, let me just... I think I'm struggling writing a fraction in here. I'm so vacant-eyed. Not a thought behind them eyes. Oh, I seem to have got it. Okay, now it seems like I am plotting out the equation of the circle here. If you're wondering what top I'm wearing, it is a Jennifer Coolidge top. I got it for my birthday. Just thought you should know. Really struggling writing this circle one, isn't it? Oh, I seem to have gotten it. Oh, go me. Anyway, so we see here the purple line is tangent to that circle there, because it intersects at one point only, and that point was minus 2, 2, which was the point given in the question. So, yeah, so I'm just talking away here. So there you go. That's how we find the equation of a tangent line. So that's the last note you're going to... Oh, don't know what I did there. But anyway, the last you hear from me. Bye. Right. So how to find the equation of a tangent to a circle? We just need to find the slope between the center and the point given. Find the perpendicular slope of that. Sub that and the point given into our line formula. Anyway, and that is all the possible questions you could be asked in Leaving Cert Ordinary Level. In the Ordinary Level Leaving Cert on the line and the circle together. Right, I hope this was some use to you, and I'll catch you later. Bye.